Imagine you're 4 years old. You walk into a room and this lady hands you this thing. And she says, this is a toy. I just found it. I don't really know how it works or what it does. Oh, but I did find out if you pull that little yellow tube that's just peeking out of the purple tube, it makes a squeaky noise. And then she hands you the toy. What do you do with it? You probably are going to squeak the squeaky yellow part. And then you're going to think, what do the other tubes do? So you might look inside the black tube, and you'll actually see a reflection of your face looking back at you. Or you might discover that those little different colored tape on the bottom, they make musical notes play. And if you really explore it for a long time, you'll probably figure out that way inside the blue tube is a teeny tiny button, and when you push it, lights come out the other end of the blue tube. Now, what if that same lady had handed you the toy and said, this is my toy. Let me teach you how to play with it. I know how it works. If you pull out this little yellow tube, it squeaks. So you're 4 years old, she hands you the toy, what are you going to do with it? What's the difference between those two conditions? They actually did this experiment with that toy and real 4-year-olds. The kids who were told this is how it works only squeaked the tube. They said this toy is boring, and they put it down. They never discovered the lights or the mirrors or the musical notes. When we hand our kids mathematics, how are we handing it to them? Are we saying, here's something fun. I don't know how it works. Let's see what you can figure out. Or are we saying, this is my domain. I know how it works. You need to learn my way. I was handling mathematics when I was in preschool in a way that was totally like playing. I went to a Montessori school, and this is what I love to do. It's a bead cabinet, and I just love to touch the beads. I love how they felt. I love how they sounded when they clicked together when you carried them. And in fact, the only two things I remember about preschool were the kid who skinned his knee on the playground and he got blood all over the climber and it was really gross. And I remember this one thing that we couldn't even play in the classroom. We had to take it out into the hallway because it was so long. It was the thousands chain. So I actually counted all the way from 0 to 1,000 and I laid down the little markers just like in this picture. And to me, that was serious play. It was the funnest thing I remember doing in preschool, and it was math. But it doesn't just have to be preschool where math is serious play. When I was in 7th grade, which is like the ultimate school is not cool time, we did hands-on algebra. And to me, it was such a game that I invented my own strategies and taught them to other kids, like, here's how you win the game. And it isn't even just manipulative, it's cool. In my pre-calculus class, I think everybody thought trig identities were this big game. And not because trig identities are like the coolest math, although I think they are really great, but it was because of how the teacher handed it to us. He said, look, there's no way that I can teach you guys how to solve these. These are puzzles. It's not about how smart you are, it's not about how good you are in school. It's just about doing a lot of these puzzles and getting good at them and coming up with your own strategies and your own way to solve these problems. So he said, hey, why don't we just do a bunch of them and get good at them together? And we had tons of permission to make mistakes. We spent a long time doing the trig identities. We were allowed to screw them up, and that wasn't like a bad thing. It was just part of the learning process. And because they're identities, this side has to come out equal to this side, so you know if you're doing it right or not. So the teacher could trust us, he could trust the mathematics, he could trust the process. He totally loved trig identities. And so he just said, go, play, have fun. And with his trust and his enthusiasm, we were totally able to value our own creativity, our own problem-solving process, to value each other's, to say, hey, how did you solve that one? Oh, that's cool, I never thought of that. And he totally valued what we've done, too. If we did it in a different way, he said, hey, come out to the front room, show everybody how you did that. And it isn't just geeks like me for whom math can be serious play. I was in a 9th grade classroom with a bunch of kids who wanted to be anywhere but geometry class until we got out the zone tools. And we didn't think they would love them. We thought it was going to be, boring, routine vocab practice. Build this, build that. The kids made an appointment to come to math class outside of class because they wanted to see what was the biggest zone structure they could build. They started inventing new shapes and saying, can we do this? Can we build it this way? Can we make a bigger one? Will you give us another challenge? We want to do more with these tools. So I'm really interested in how do we hand kids math in a way that makes them playful. And Dan Meyer started this web community, 101cues.com, and it's all about taking a video or a picture that you think is going to make somebody say, whoa. And then once they say, whoa, they're going to say, how can I figure out what's going on here? And they're going to have their own tools to be able to check their own understanding, to work with the math, to play with the mathematics. So I hope you'll join us. I'm trying to post some of my ideas at the Math Forum Pals blog, and on 101qs.com you can post your own stuff and see what other people did to engage kids in mathematics, to let them self-correct and explore independently, and to value their thinking and let them value their own math.